Hello students, today we will be looking at one of the previous year GATE question from the subject Manufacturing Engineering from the chapter Forming Process, and inside Forming Process we will be looking at question from wire drawing operation. As you all know that wire drawing operation is very much similar to the extrusion process. The only difference is in wire drawing operation we make use of the tensile forces at the outland end of the die, while in an extrusion process we apply the compressive forces at the inlet end of the billet. This small information or the small difference between these two processes helps us to do most of the previous year GATE questions. This particular question is very much similar based on this particular same concept. Let's see what this question is all about. This question was asked in GATE 2008 and it is a linked question. The information given to us is 8 mm diameter annealed steel wire is drawn through a die at a speed of 0.5 meters per second to reduce the diameter by 20%. The yield stress of the material is 800 megapascal. So this is the information given to us for the linked question, and on the basis of this information they have asked two questions. The first question is, neglecting the friction and strain hardening, the stress required for drawing in megapascal is the option A 178.6, option B 357.0, option C 1287.5, option D 2575.0. And the next question which they have asked based on the same question is the power required in drawing operation in kilowatts, and four options are given to us. So before we do any question, especially in manufacturing engineering, try to write down all of the information which is given to you. So the information which is available to us in this particular question is as follows. We have the given data. Initial diameter, DI 10 mm, final diameter D naught 8 mm, speed of drawing 0.5, yield strength of the material, let's represent it by SYT as 800 megapascal. So this is the information which is given to us, and in the first part or in the first question it is asking us what is the drawing stress. For drawing stress we have a very simple formula. Drawing stress is given as K ln AI by AF, where AI refers to initial area of the wire. Let me write down, where AI is initial area of wire, initial area of wire, and AF refers to final area of wire. Area refers to area of cross section of wire. So basically we are talking about that there is a die which is decreasing its cross section, and a certain wire is sent into this particular die. A certain wire is sent into this particular die whose area of cross section has been reduced. So this AI refers to area of cross section from this side and AF refers to area of cross section of this end. And as it is a drawing process, so we will be applying the force on this end, which makes this particular process as tensile forces driven process. So in this particular part, we can write it as K multiplied by ln di by df whole square, and this is within the log. So we can further write it as 2k ln di by df. What is K? K refers to the yield strength of the material. So we were to calculate the drawing stress, that's represented by sigma d, which is given by 2k ln di by df. All of these information are available to us. We are having initial diameter, we are having final diameter, we are having the K value as well, which is the yield strength of the material. So let's put the values. Sigma d is equals to 2 into 800 multiplied by ln initial diameter of 10, final diameter 8. After calculating, you will get it as 357.03 megapascal. So this is the answer to our first question. We have calculated drawing stress with the help of the simple formula, and then option B is correct. Let's move on to the second part of this question. So moving to the second part of this question, in which the power required for this drawing operation is asked. So let's write down the formula for power. We all know that power is given as force into velocity. We all know this simple expression that power is equals to force into velocity. What is force? In this particular expression, the force, we have already calculated what is the mean stress acting at the outlet end of the wire drawing operation. So I will just write down here the drawing stress multiplied by area of cross section at the outlet end, final area of cross section. So the drawing stress, as we have already calculated in the previous part, it was 357.03, and final area of cross section is pi by 4 multiplied by 8 square. And after solving this, you will get it as 17.946 kilonewton. And once you get this particular value of force, we are already given the value of velocity, which is 0.5. So we will obtain power as 17.946 multiplied by 0.5, which will come out to be, the units are very important. Whenever you are solving the questions like this, the units are very important. Here it is kilonewtons. So this particular answer would be 8.9 kilowatts. So out of the given options, the option A is correct. So I feel this particular question is very much clear to you. The only formula which we have used is the drawing stress formula, which was an empirical formula. We have used that expression to calculate the drawing stress, and after that we had utilized that information of basics which are involved in the drawing process. That is, it is using the tensile stresses. The tensile stress is applied at the outlet end of the die to make the wire out of a given billet. So we have used the final area of cross section. I hope it is very much clear. Thank you so much. All the very best for your game.